Hi everybody, welcome back. So we are continuing our study of probability, and here we're going to, last section we talked about independent events and how it relates to something called the multiplication rule. Now we're going to talk about mutually exclusive events and how it relates to the addition rule. Okay, so first definition. Very simple. We say two events are mutually exclusive if they can never occur at the same time. Hopefully that's pretty straightforward. An example would be having a birthday in October and having a birthday in April. There's no way the same person can do that, right? So we would say A and B are mutually exclusive. Now, of course, also in April is not in fall, so also B and C are mutually exclusive. Okay, A and C, of course, are not because October is in fall, so A and C would not be mutually exclusive. Another example: let's say we roll a die, rolling a 2 and rolling a number less than 4. Well, those are certainly compatible, right? Because 2 is less than 4. So these are not mutually exclusive. In fact, A is actually, in terms of sets, A is actually a subset of B. Same thing, A if rolling a 2 is not mutually exclusive to rolling an even number, but rolling a 2 is mutually exclusive to rolling an odd number, right? Because 2 is not odd. So we can see that A and D are mutually exclusive. And also, rolling an even number and rolling an odd number would also clearly be mutually exclusive, right? Okay. So basically what that means, mutually exclusive means that, if you're talking about events anyway, if you look at the sets, the outcomes that correspond to one event and the outcomes that correspond to another, they don't intersect. Okay. Now here is another case. If we like we can illustrate this using Venn diagrams, and we can see that some people like Venn diagrams, including one person very high up in the federal government right now. But they're fun to look at. They're pretty straightforward, right? Where we can see they intersect, and this is the intersection. In this experiment, a card is selected from a standard 52 card deck. If A is the event that a card is a 7, and B is the event that a card is a heart, well, we can see what the intersection is, right? These are all this is the, let's say this would be the outcomes from B, and this would be the outcomes from A, and we can see that there is exactly one outcome, right? It's the 7 of hearts. There's one outcome in the intersection. Okay, so A and B are not mutually exclusive. Okay, well, we can clearly see that having a card being a 7, a card being a king, these certainly are mutually exclusive, right? There's no intersection there. These are the kings, so this would be C, and this would be A again. So we can see that A and C are mutually exclusive. Okay. So now what we want to talk about is how does this relate to probabilities? We can see right now that let's going back to here in this case, the probability of A is, well, there are 4 outcomes in A, and that would be 4, so this would be 4 out of 52. Okay, the probability of B is there are 13 hearts, right? So the probability of throwing a card being a heart would be 13 out of 52. Well, we can't just add these up, because if we count all of these and we count all of these, we're counting this outcome twice, right? So we have to take that into account. So the probability of well, first of all, let's denote that the probability of A and B is just, there's only one outcome where they both happen, and that corresponds to this event of the 7 of hearts, so that would be 1 over 52. And so if we want to talk about the probability of A or B, that corresponds to the union of all the outcomes in A and all the outcomes of B. That's all of these. And if we were to count them up manually, there'd be 13 here, plus 13 plus 14 plus 15 plus 16. So that would be this should be 16 out of 52. And that's different from just adding if we just add these two up, we would get 17 out of 52. Okay, so what we had to subtract this. And actually what's going on here is we basically added the probabilities, but then we subtracted the probability of their intersection. Okay, so that's how we got that 16 there. And what we've just sort of illustrated here is the addition rule. The addition rule says that if A and B are events, then the probability of A or B happening is equal to the probability of A plus the probability of B minus the probability of A and B. Now, if A and B are mutually exclusive, then A and B can never happen, so this would just be 0, right? Because this is 0, it can't happen, so this would just be the probability of A plus the probability of B minus 0. So that's how we get this. So a few examples to see how this works. If we wanted to talk about the probability of a spade or king, this is basically going to be the same idea. This is the probability of a spade. This is, of course, the experiment where we pick a card from a deck, plus the probability of a king, minus the probability of a king and spade. Okay, so once again, this would be, there are 13 spades, there are 4 kings, and there's 1 spade. There's 1 king of spades, right? So this would be 16 over 52 again. If we wanted to talk about the probability of a club or a face card, this would be the probability of a club plus the probability of a face card minus the probability of both. Okay, now the probability of a club, there are 13 clubs in the deck, so this would be 13 over 52. A face card is either king, queen, or jack. Okay, so there are, for every suit, there's 3 face cards, there are 4 suits, so there are 12 face cards in the whole deck. So this would be plus 12 over 52. And then we have to subtract the probability of the club and the face cards. So in particular, we're talking about the king of clubs, the queen of clubs, and the jack of clubs. Okay, there are 3 of those. Okay, 3 ways this can happen. So this would be minus 3 over 52. So this would be 13 plus 12, that's 25. 25 minus 3 is 22. So this would be 22 over 52. So that would be the probability of that. And the probability of a red suit or a 5. Okay, well, remember, half the deck are either hearts or diamonds, so half the deck is red. So this would be the probability of a red suit is going to be 26 over 52. The probability of a 5, there are 4 5s in the deck, so this would be plus 4 over 52. And then we subtract the probability that is red and 5. Okay, there are 2 red 5s in the deck, right? The 5 of hearts and the 5 of diamonds, so this would be minus 2 over 52. So that would be 26 plus 4, that's 30. 30 minus 2 is 28. So it's 28 over 52. Okay. All right. So we'll take a break right here, and then we'll finish this up with some more examples.